Hello everyone. Today my partner Yogesh Meena, roll number 315, and me, Yogesh Kumar, roll number 316, are here to present our topic on assignment. The topic of our assignment was to review past 5 years research papers, basically relating to fluid mechanics. So the first one which we're gonna review is the topic is flow and fast Fourier transform analysis for tip clearance effect in an operating Kaplan turbine. So, starting with the introduction, Kaplan hydro turbines are widely used in hydropower plants because of their high efficiency over a wide range of operating conditions. A propeller type turbine is suitable when the load on the turbine remains constant. For Kaplan turbines design, and operation, tip clearance, which is formed by rotating runner blades and the stationary chamber, is essential. Because of the clearance gap between the blade tips and the turbine casing of axial turbo machinery, rotor blades tip leakage flows are expected. In both compressor and turbines, the tip region flow tends to include a pressure driven oblique leakage flow from the pressure side to the suction side of the blade. Uh, Moving further, at present, the conventional method for monitoring the stability of fluid machinery include pressure fluctuation, acoustic output, and other inspections. In running monitoring and the pressure fluctuation is major focus to identify operating conditions. To extract the characteristics of fluctuating signals, mathematical tools like fast Fourier transform analysis is often utilized where the signal features in the time domain, frequency domain, or amplitude can be obtained. Now, moving to the numerical analysis. Here in ANSYS, this research paper has analyzed geometrical model and meshing. The 3D geometry of horizontal prototype Kaplan turbine was selected to analyze the flow characteristics of hydrological aberration as shown in the figure 1. Here we have shown the 3D geometry of prototype Kaplan turbine, and in the second there is the 3D scanned runner blade shape. Here's the shape. Moving further, here they have provided the block diagram for research of this study. First, they did 2D drawing, then 3D modeling, and 3D scan shape, then meshing and physics analysis, then moving forward to the numerical performance analysis, and then the fast Fourier transform. Then we have the results. Here, figure 4 shows the runner vane of Kaplan turbine. Here is the tip clearance gap of the Kaplan turbine, and here is its view from downstream side. Here in ANSYS, they have created 3D unstructured prism grids by parts of Kaplan turbine. Here it is casing, this is the runner, and this is guide vane and draft tube. Now moving further, they have also provided the governing equation, which is this one. The numerical analysis of fluid flow was based on continuity and momentum equations, which are expressed in equation 3, this, and the equation 4 respectively. Now for numerical simulation, the turbine domain was considered with its steady state incompressible flow, the runner domain was rotating on the z-axis at given speed, and the casing and draft tube were on stationary domain. The domain which is shown in figure 8, here it is this, the turbine domain for computational analysis. Now calculations, here it is shown how they calculated. And finally the efficiency of the turbine was expressed as this, the ninth equation, which is omega T shaft upon rho Q GH, where rho is density of water, G is gravitational acceleration, and H is the turbine working head. Now basically in this, before moving to the results, we basically did review on the Kaplan turbine is an axial propeller type turbine that simultaneously control guide vanes and runner blades, thus allowing its application in wide range of operation. Here, turbine tip clearance plays a crucial role in turbine design and operation, as high tip clearance flow can lead to a change in flow patterns, resulting in loss of efficiency and finally breakdown of hydro turbines. This research paper investigates tip clearance flow characteristics and undertakes a transient fast transform, which is FFT analysis of a Kaplan turbine. Here in this research paper, the study of the computational fluid dynamics was used to investigate the Kaplan turbine performance with tip clearance gaps. In particular, a parametric study was carried out, including the different geometrical parameters such as tip clearance between stationary and rotating chambers. In addition, an FFT analysis was performed by monitoring dynamic pressure fluctuations on the rotor. Here, increase in tip clearance was shown to occur with decrease in efficiency owing to the unsteady flow. With this study in focus on analyzing the flow of the tip clearance and its effect on turbine performance as well as hydraulic efficiency, this research aims to improve the understanding on the flow field of Kaplan turbine. Now, these are the results. Here in this diagram, the tip clearance is shown, velocity and pressure profiles between the runner blades and the shroud. Moving to the conclusion, this study was based on steady and unsteady flow analysis with varying tip gaps between the runner and the discharge ring of Kaplan turbine through computerized flow analysis. The computerized flow analysis was done on ANSYS by the research paper authors. Here is the nomenclature and these are the references. Moving to the second research paper, which is titled Flow Analysis of Kaplan Hydraulic Turbine by Computational Fluid Dynamics. Here in this research paper, a hydraulic turbine, which basically they introduce us with what is hydraulic turbine in a rotatory engine, and then the use of a numerical method such as CFD in this design process is used. Many researchers considered CFD based analysis as a reliable tool to design the hydraulic machine, as CFD predictions of main flow features are becoming quite accurate. In axial flow turbine, the water passes through the series of blades rows and blade profile is designed at different section from hub casing to get the best performance. Now, to maintain efficiency over wide range of low head units, they have double regulated systems. Now, in this paper, basically they introduce us with their CFD which they have used, and the 3D viscous flow simulation with SSTK turbulence model is employed to analyze the performance of axial flow turbine. That is Kaplan turbine, which has specific speed of 413 mega kilowatts and a head of 15 meters using ANSYS 14 software. Now, moving to the geometric modeling and boundary conditions. Kaplan turbine consists of spiral casing to provide uniform to wicket gates blade with the hub called runner and draft tube. There are 15 aerofoil wicket gates and 5 runner blades in this study model, analyzed by available design standards. Here is the summary mesh data which they have used for computational analysis. Moving to computational flow parameters, computational fluid dynamics analysis or CFD provides pressure and velocity distribution for each domain in the form of pressure and velocity profile. Hydraulic parameters are calculated for performance assessment of Kaplan turbine under different wicket gates openings by using the following formulas. Let me zoom it for you. These are the formulas of specific speeds, available power, pressure, head loss domain, head available, and turbine efficiency. So before moving to the results and discussion, this paper basically summarized in a hydraulic power plant, the potential energy of water is converted into electricity through hydro turbines and the generator. Kaplan turbine, which we know is an axial flow turbine, consists of wicket gates mounted to its in the stationary casing and the moving blades attached on the hub. This combination of wicket gates and plates create a blade cascade to regulate the variable discharge over the blades in order to maintain the efficiency of turbine over wider range of operation. In this paper, they have used CFD, which is one of the tools to evaluate efficiency of alternate design of turbines for optimization. Under this paper, CFD analysis has been carried out to evaluate the part load efficiency of Kaplan turbine under the different operating conditions, so as a range of part load efficiency for the Kaplan turbine is determined. Here they have shown the results which they did on ANSYS 14 software. Here is the streamline pattern of pressure variation at different WGO. Here are at different velocity variations. These are the graphs. The head losses and the efficiency, which is at B, trend at different WGO in the turbines. Moving to the conclusion of this paper, in the present study flow and analysis of Kaplan turbine has been carried out using the CFD package ANSYS 14 at different wicket gate openings. The numerical simulation results were found in order to be consistent and with the real situation. It shows that ANSYS 14 is able to generate good computational result in an efficient way. Here are the references shown. Here we move on to the third paper, which is Fluid Mechanics from the Beginning to the Third Millennium. In this paper, they have basically analyzed about the history of fluid dynamics, but this does not intend to be a history subject, but a few milestones that are recalled in this paper in the next 5 sections that they have provided. The art of fluid mechanics arguably has its roots in prehistoric times, when streamlined spears, sickle-shaped boomerangs, and fin-stabilized arrows evolved empirically. Here modern man also unknowingly yet artfully applied fluid flow principles to avoid certain technological goals. Now, for centuries, farmers knew the value of wind breaks to keep the topsoil in place to protect fragile crops. This is basically an application of fluid. This is the history milestones that they have provided. History of the universe timeline. All dates are approximate and the time is highly non-linear. Now moving forward, here is Leonardo da Vinci's sketch of water existing from square hole. This is in circa 1500. Here they have shown some fundamental equations and some closing equations, Navier-Stokes equations. These equations are dependent values they have shown here. Here they have, in the next section, they have shown the Brand breakthrough, then the switch from art to science in fluid, and the basically computer which is used in today's time to analyze fluid flows and whatnot. During the 1990s, the supercomputer power approached the teraflop, which is 10 to power 12 floating point operation per second. This provides us with more accurate results, and thus more research can be done on this topic. Then they talked about the future. As argued in the previous sections, the computer of the future may be able to numerically integrate any problem in fluid mechanics. That is, now basically this paper talked about the history of fluid flows and fluid mechanics. Although the christening of discipline is relatively recent undertaking, fluid mechanics goes back to the time of archaic Homo sapiens. The art of fluid in motion was born when quite empirically, unceremoniously, and without a hint of what either a fluid or mechanics is. The resourceful inhabitants of planet Earth discovered that a streamlined object travels farther as compared to a blunt one. Great changes took place during the first half of this century um, in both the teaching and the research of discipline, and it appears that the subject is yet uh, set for another upheaval as we approach to the third millennium. This paper discusses those past and future evolutions of fluid mechanics. Here are the references. Now my partner Yogesh Meena will continue.
First of all, a review of a review on a dynamic analysis of pattern wheel turbine. Mr. Akshay, introduction part. Peloton turbine has been widely used in hydroelectric plant around the country. The study of dynamic behavior of Peloton wheel turbine has been a greater importance in order to understand the operating and failure related with the mechanism. Rotating machinery consists of many structural elements such as a shaft, disc, blade, bearing, seal, damper, casing, and please zoom fundamentation. Fundation. The whole machinery as a assembling the part structure has global dynamic characteristic. The dynamic properties of most important in roasting machinery typically including the critical speed, force responses and stability of modes. The critical speeds of a rotor defined as the rotational speed at which the speed dependent modal natural frequency. So find out the natural frequency of the system important for safety operation. Literature review. The dynamic behavior of flexible rotor system subjected to base inv- investigated theoretically and experimentally by Aman Rajak. They had developed a mathematical model for a energy of the system of the equation of motion has been derived using an energy method. They assume the Peloton wheel driven as a simple rotor disc. The assembly of rotor the assembly of rotor system as shown in figure. Simple rotor disc system. Next page. Some student work on this topic listing Chong have a study and say infinitely element software to model the main shaft system in the hydro turbine generating unit. On the basis, it takes the models analysis and using comparable diagram calculate the critical speed of rotation. Ujman Nawaz, next one, have study the differential equation of a hydro system and based on the differential method for calculating the flow and water through the penstock uses equation of motion and contributing these equation used graphical method and for solving a transmit similarly established problems. Next one, Chongwon has studied the frequency speed diagram, often the Campbell diagram that the along rotating machinery. The construction of the convention frequency speed diagram discuss relation to the rotor dynamic complex rotor system. And Prakash K. Dukkan have designed the causing of four-jet vertical Peloton wheel turbine is carried out considering the size of shape and casing. The casing should be heavy enough strength to meet mechanical and structural requirements such as to withstand the dead weight of the generators. The force developed in the force the force developed the force developed in the main branches pipes load due to various accompaniment mechanism. Next, Ji Li and Lexing Chongling has presented the numerical method which could simulate the vibration spiral casing structure that caused by the water flow in a turbulent flow through the flow passage of turbine model is accomplished by solving NS equation. These are diagram these are diagram of finite element model to spring casing. J.C. Chavez have analyzed a 16-bucket Peloton impeller for a hydraulic plant in a convolution a plant with two turbo generator with a thermodynamic capacity 2.3 MW. Each metallographic analysis were performed on the implied zones near the crack, including analysis. Aman Pothe have present the producing fluid dynamics analysis Platin turbine Kimti hydropower plant in Nepal. The purpose of CFD analysis is determine torque generated by the turbine and pressure distribution in bucket for further work on the fatigue analysis. And next page. And these are some more students to work this model. Conclusion. From the From the literature review, it is seen that very less work has been done by the field dynamic behavior of Peloton wheel turbine and their effect in design and operation. Forced vibration is that the mode of vibration these may cause a seriously damage of the machines. Aman Rajak, Ujman, and Jack Ling, an author, applies the dynamic characteristics to of system by find the natural vibration of systems. The mathematical model for dynamic behavior of Peloton turbine assembly that thus the fortunatively and the analytic solution natural frequency was the performed and abstract of this overview. Abstract. Peloton wheel turbine is generally used of mechanical power generation in a hydraulic power plant. Vibration produced in system is forced vibration, the dynamic characteristic of a hydro turbine power plant. Power depend heavily change a load distribution. Thus, the hydro turbine exhibit high monolinear non-stationary system whose characteristic to significantly with the empirically with actual frequency of the turbine cause of formation of resonances. These resonances forms are increased in chances of the failure of turbine and buckling of deformation of shaft. This next review paper here is the next review research paper. Perform analysis of Peloton turbine under different operating condition and experimental study. Introductions page. The, wa- the water power is considered as one of renewable energy resource which are large potential changing of fossil energy for generating electricity. The Peloton turbine or Peloton wheel turbine is a type of turbine that commonly used to hydroelectrical, also described impulse type of turbines. The result the result determines that the electrical it produced by the turbine can be utilized running a small pump with a tube well increase the total discharge. Next. These are nomenclature exper- experimentally performed by description of the experimental model. In this study, the experimental have been performed on a test bench model as shown to investigate the performance of Peloton turbine for the different nozzles, diameter, water head, and water discharge. A one rotometer has been used to measure discharge of water through the nozzle. The water presume volume flow rate has been set to vary from 40 liter per minute to 120 per meter liter. And these are the experimental setups. ऊपर. These are calculations and formula used experimentally procedure. As far the performance of Peloton turbine is involved a curtain of D has been firstly fixed in the testing device, a centrifugal pump, the nozzle, the amount of water has been adjusted by the regulating gate valve, the actual water discharge and pressure have been recorded by rotometer device and pressure gauge respectively has been the firstly measured by using the tachometer with the zero buck load maximum field velocity and then the brake load is gradually increased until the reaches maximum. This procedure has been iterated for each D by changing Q and H. Influence of different nozzles. In order to describe the effect of D on H and P, the variation of H and P, and these are the some describe. These are graph of water flow rate L per minute and water flow rate. Variation of H and P as a function of Q varies D. Conclusion and final remark. The work involved the experimentally study in order to dominate filter the effect operating condition on the performance of material and it has 12 cup bucket and the describe the wheel confirmation. Water has been used is a working fluid and the water experimentally work have been performed different nozzles, diameters, water discharge and water first. As D is increased, the water head is linearly reduced due to decrease the water potential energy and hence Q is increased as Q is the increased the keeping D fixed P in gradually increase a higher value of P in has been observed by D is equal to 9.5 meter avoiding the maximum H has been obtained at these diameters. It is also evidently that maximum decrease the increasing in D, which mean the inversely effect on N. Next, variation. Here, these are the graph of variation of N as a function of Q of various D. A constant turbine speed at N is equal to 500 rpm and B constant output power 20 watt. And these are the all graphics in this experiment. Declaration and completing interest. The author declared that have no no non-competing financial interest or personal relationship that could have appeared to influence the work report on this in this paper acknowledgement. The author gratefully acknowledged Northland Technology University Engineering Technological Modeling Laboratory support of this work. These are the references. Abstract. In this article is an experimental work has been carried out to examine the effect of varying operating condition on performance of Peloton turbine. The experiment has been performed for a various nozzle jets, diameter, volume, flow rate, and pressure head. The experimental result display that the rise in D lead to reduce the input power due to decrease in H for certain nozzle diameter. The result indicate that the maximum brake power increasing with the increasing of Q owing to increase the torque and consequently the optimized operation condition can be achieved when using a smaller D and higher Q. The best turbine perform has been found when using D 9.5 mm and Q 85 liter per minute, owing to produce higher efficiency and cover the large range. The power that generated by turbine by recognizing or recognize the effect of related parameters, it now possible to generate higher electric power in hydraulic power plants than operating by using the pellet turbine. Thank you.
So these were the 5 papers that we studied. Thank you for listening.